Protection and restoration of Chesapeake Bay needs to take into account that we are experiencing climate change impacts now. These include sea level rise, increasing water temperatures and amounts of rainfall, ocean acidification, and other related impacts. The long-term prediction for our area in regards to climate change is for a warmer and wetter climate. This means that we should expect more rainfall and hotter summers. But it also means that we will have more mild winters. After the long, cold, and snowy winter we just had, it's hard to understand these longer-term trends. 2013 was wet and warm. Although it was a quiet year for extreme events like hurricanes, July 2013 was one of the hottest on record. It also had above-average rainfall for that month. In addition to reporting the health of Chesapeake Bay, we want to provide some kind of measure of the resilience of Chesapeake Bay to climate change. What does that mean? Well, resiliency is the ability of an ecosystem to withstand change in its environment. For example, how well will coastal wetlands withstand sea level rise? Will they disappear altogether? How well will submerged aquatic vegetation, those underwater plants that provide habitat for important bay organisms like fish and crabs, survive higher water temperatures, now and into the future? These are important questions to ask now so that we may protect and restore Chesapeake Bay in the face of climate change. This project, called the Climate Change Resilience Index, addresses several climate change impacts. They are sea level rise, increasing water temperatures and increasing amounts of rainfall, increasing storm frequency and intensity, and ocean acidification, which is represented by lowered pH levels. The indicators that we are planning on using are coastal wetlands, submerged aquatic vegetation, bacteria and other pathogens that are important for human health, and fish and shellfish recruitment. I'm going to use coastal wetlands as one example of how this project will be implemented. First, the climate change impacts that affect coastal wetlands are mainly sea level rise and warmer temperatures, but by far sea level rise is the main impact on coastal wetlands. Second, we determined the things that make coastal wetlands resilient to climate change. They include things like adequate sediment supply to build marshes, migration corridors, which are upland areas where wetlands can move to, decreased erosion from wind and waves, and healthy submerged aquatic vegetation beds and oyster reefs that protect wetlands from these winds and waves. Third, we determined the main contributions that will help wetlands be resilient to climate change. They are suspended sediment concentration and migration corridors. As we move forward with this project, we will explore and develop analytical tools and ecological thresholds to determine how resilient wetlands will be to climate change. This is only one example of the indicators we have chosen to be included in the Climate Change Resilience Index. The other indicators are submerged aquatic vegetation, bacteria and pathogens, fish recruitment, and oyster recruitment. For next year's report card, we expect to have a full list of indicators and their resiliency to climate change, so stay tuned.